Welcome to Decoding Bias, where we explore the fascinating intersection of human psychology and artificial intelligence. I'm Sarah Chen, and today we're diving into something that affects AI systems in ways many people don't realize: cognitive biases.
Thanks for having me, Sarah. I'm Prasenjit Banerjee, architect with ABSYZ Software Consulting, and as someone who's spent the better part of past 3 years working on AI models and AI ethics and development, I'm excited to share insights about how our human thinking patterns can unknowingly shape these powerful systems.
Today, we'll be exploring 10 specific cognitive biases that significantly influence AI development and training. These biases can have profound effects on how AI systems make decisions and interact with users. I think our listeners will be surprised to learn just how much our human quirks can impact these supposedly objective systems. Let's start with the Dunning-Kruger effect. Mr. Banerjee, I've seen this play out in tech startups where teams rush to implement AI solutions. Can you explain what this bias is and its impact?
Absolutely, Sarah. The Dunning-Kruger effect is fascinating because it's essentially about not knowing what you don't know. I remember consulting for a startup that was developing an AI-powered medical diagnosis tool. The development team was so confident in their basic understanding of medical terminology that they didn't think they needed extensive medical expertise in their training data review.
What happened in that case?
The system ended up missing crucial medical context and cultural factors that any experienced healthcare professional would have flagged immediately. It's a perfect example of how overconfidence in limited knowledge can lead to significant oversights in AI development.
That brings us to our second bias, the halo effect. How does this manifest in AI systems?
Think of it like this. If you meet someone well-dressed from a prestigious university, you might automatically assume they're intelligent and competent in all areas. AI systems can develop similar biases. I worked on a project where an AI recruitment tool was consistently favoring candidates from certain companies simply because these companies had good overall reputations.
That's concerning. How did you address that?
We had to completely restructure how the AI evaluated candidates, breaking down each skill and qualification independently. It's like teaching the system to look beyond the halo of a brand name and assess each attribute on its own merits.
Let's move on to the false consensus effect. This is something I find particularly interesting in AI development teams. What have you observed about this bias?
You know, I saw a perfect example of this recently. A team in Silicon Valley was developing a voice recognition AI, and because everyone on the team was fluent in English with American accents, they assumed their test data was comprehensive enough.
I can already see where this is going.
Exactly. When they launched globally, the AI struggled with various accents and dialects. The team had fallen into the trap of thinking their own experiences represented everyone else's. It took months of additional training and diverse data collection to fix the issue.
That's fascinating. What about imposter syndrome? How does that affect AI development?
This one's more subtle but equally impactful. I worked with a brilliant data scientist who discovered a potential bias in a financial lending algorithm, but she initially hesitated to speak up because she was new to the team.
What was the outcome?
By the time she gained the confidence to voice her concerns, the model had already been implemented. It turned out she was right. The algorithm was inadvertently discriminating against certain demographic groups. If imposter syndrome hadn't held her back, we could have addressed this much earlier.
So it's not just about the technical biases in the AI itself, but also about how human psychological factors affect the development process?
Precisely. These human elements can be just as influential as technical issues in determining whether an AI system will be truly fair and effective.
Now, let's talk about two biases that often work together: confirmation bias and anchoring bias. Could you explain how these show up in AI development?
I can share a really interesting case that demonstrates both. There was this healthcare AI system being developed to predict patient outcomes. The development team started with a dataset that showed higher complications in certain ethnic groups.
And I'm guessing this initial data became their anchor point?
Exactly. Instead of questioning whether socioeconomic factors or access to healthcare might be the real drivers, they unconsciously kept looking for data that confirmed these ethnic correlations. It's a classic example of both anchoring to the first dataset and then seeking confirmation of those initial patterns.
What were the consequences of these biases?
The AI ended up recommending more aggressive treatments for patients from these ethnic groups, regardless of their actual health status. It took an external audit to identify this issue.
Let's move on to two other fascinating biases, the availability heuristic and the framing effect. Can you explain how these impact AI systems?
Of course. I recently encountered a perfect example with a crime prediction AI system used by a police department. The system had access to social media posts and local news reports, which tend to over-report crimes in certain neighborhoods.
So the AI was making decisions based on what was most readily available?
Exactly. Because these areas had more media coverage and social media discussions about crime, the AI system started flagging them as high-risk zones, leading to increased police presence. Meanwhile, crimes in wealthy neighborhoods were often underreported, creating a skewed picture of reality.
And how does the framing effect play into this?
Well, it's all about how we present the data to the AI. In another case, a loan approval system was labeling applicants as either high risk or payment challenged. Same meaning, but the second term led to more favorable outcomes because it was framed differently.
That's fascinating. So even the labels we choose can influence the AI's decision-making?
Absolutely. We saw a complete shift in approval rates when we changed how data was categorized and labeled. The same applicant could be viewed differently just because of how their information was framed in the training data.
Do you have any suggestions for avoiding these biases?
The key is to consciously diversify data sources and regularly audit how information is labeled and categorized. We need to ask ourselves, are we letting easily available data dominate our AI's worldview? Are we framing information in ways that might create unintended biases?
Now, let's discuss two biases that often go unnoticed: the bandwagon effect and hindsight bias. What's your take on how these affect AI systems?
Let me share an interesting case from social media content moderation. We had an AI system that was designed to flag inappropriate content, but it started following trending patterns a bit too eagerly.
How did that manifest?
Well, if certain types of content suddenly became viral or widely reported as problematic, the AI would become overly aggressive in flagging similar content, even when it was actually harmless. It was essentially jumping on the bandwagon of popular opinion, rather than maintaining consistent evaluation criteria.
And what about hindsight bias? How does that come into play?
I saw this recently with a financial prediction AI. After the 2020 market crash, developers were convinced that their AI should have seen it coming. They adjusted the model to be super sensitive to similar patterns, but this actually made it less effective at predicting future market movements.
Because they were designing based on what they knew after the fact?
Exactly. They fell into the trap of thinking it was obvious in hindsight. This led to an overcorrection that made the AI overly cautious and prone to false alarms. The reality is, not every market dip is the beginning of a crash, but the AI became biased towards seeing patterns that might not actually be there.
How can developers guard against these biases?
For the bandwagon effect, it's crucial to implement stable evaluation metrics that don't shift with trends. And for hindsight bias, we need to acknowledge uncertainty in our models and resist the urge to overfit based on past events that seem obvious now but weren't predictable at the time.
After exploring these fascinating cognitive biases, what's your key takeaway for our listeners about their impact on AI development?
The most crucial point is that AI systems are fundamentally shaped by human decisions and perspectives. Every choice we make in development, from data selection to model architecture, carries the potential for these biases we've discussed.
How can organizations work to address these biases effectively?
It really comes down to three main things: diverse development teams, rigorous testing processes, and continuous monitoring. When we bring together people with different backgrounds and experiences, we're more likely to catch these biases early.
And I imagine transparency plays a role too.
Absolutely. Being open about potential limitations and biases in our AI systems isn't a sign of weakness, it's responsible development. We need to normalize discussing these challenges openly and working collectively to address them.
Any final thoughts for developers and organizations working with AI?
Remember that building equitable AI isn't just about technical excellence. It's about understanding human psychology and creating systems that work fairly for everyone. The future of AI depends on our ability to recognize and address these biases head on.